Hey everyone, in this series we're going to be looking at some SQL coding. So SQL stands for Structured Query Language. Basically what we're going to do is we're going to look at the coding equivalents of some of the tasks that you already know how to perform, such as creating a table, adding columns to a table, adding a row so you actually add a value to a record. And you could say, well, why do I need to know how to do that? I already know how to do that manually. The main reason is that you may at some point need to create a fully automated process that requires or should actually prohibit any kind of human interaction or human intervention. Like, for instance, maybe at the end of every day, you want to create a table that stores a backup of all the day's transactions. Well, you don't want a person to have to come in here and create a table manually. What you would do is you would use the create table command so as that you have this fully automated process doing it for you. So let's get into that. So the first thing I'm going to do is I'm just going to create a blank form with a single button. The reason for it is the code will get executed when I click on the button. That way it's on demand. So as I mentioned, some of these tasks may actually run at night, triggered by it's 12:01 a.m. So let's do a backup of the day's activities, whatever. So there's different ways to make SQL code execute. We're doing it in this fashion, again, so it's on demand. So we're just going to click on blank form. I'm just going to take a second to get rid of the record selectors. Really has no impact on this particular project, but it's a good habit to stay into because the record selectors may enable your users to navigate the database in a way you don't want them to. So just going to go to View. We're going to go Design View. We're going to go to the Design tab. We click on the Property Sheet button. And for record selectors and navigation buttons, I'm just going to set those to no. Again, has no impact on this particular project, but it's a good habit to stay in. Now what we're going to do is we're going to click on button, just left click, drag, and it really doesn't matter what size the button is. You standard Windows warning, you can just click on open, and then we cancel out of this because we don't want to use a wizard. We want to manually attach the code. If you want, you can change the caption. You just highlight, and we'll just say, run it, execute. Nice if I could type. So run it, execute, whatever. And so that gives us the basic way to execute the code. So with the button selected, we're now going to click on the Event tab. And for the on-click event, in other words, when you click on the button, something's going to happen. Click on the ellipsis, click on Code Builder, click on OK. And give ourselves some spaces. So what we're going to do here is there's going to be a standard introduction to each SQL command. That is docmd run SQL, so run SQL. And then what follows will be the SQL command. The entire command needs to be in quotes. So I'm just going to paste this here so I don't make any mistakes, but we'll walk through it. So as you can see, the entire thing is surrounded by quotes. So this first command is create table. Now, one of the things I like about SQL is it's self-documenting, because create table, very obviously, creates a table. That's what I mean by self-documenting, that the code states exactly what it's doing. So you have create table. Then you have the name of the table. So notice there's no apostrophe surrounding it, no quotes or anything. You just straight out write the name of the table. So create table, it will be called our table. Then the next part has to be completely surrounded in parentheses. The next part, or should I say this part, is the creation of the actual fields within the table plus the type of data the field will store. So the field name is surrounded by brackets, square brackets, and it's the name of the field. In this case, it's EE_name, so employee name. Then a space, and then this is the type of data. So it's going to store text data. So let's go ahead and save that, and it's going to want us to save our form too. Now let's jump back. And now what's going to happen is when we click on run it, it will create that table with that field, and it will be able to store that data type. So we click on view, we click on run it, and sure enough, our table appeared over here. Double left click on it to open it up. Sure enough, _name. Now we'll go to view, design view, and sure enough, it's short text. So it executed exactly what we wanted it to. Okay, so let's now look at our next example. So we've created a table, so now we want to put a value into that table. So let's go to view, design view, button is already selected, on click event, click on the ellipsis. First thing we're going to do is we're going to remark out this statement with a single apostrophe. We do not want to create another table again. Maybe at the end, we'll delete the table and then have all these run at once so you can see, again, an example of a fully automated process. But right now, we have to learn the individual statements. So, same format, docmd.run SQL. And I'm going to paste this in again so I don't make any typos. So, again, the entire command is surrounded by quotes. This time, the command is insert into, and then again, we see the name of our table. So you're seeing a similar format. This is saying create a table of this name. This one is saying insert into this table by this name. The next part again is surrounded by parentheses. It is the name of the field. The difference is in this case, the field had square brackets. Here it does not have square brackets. Outside of the brackets, you have the word values, because that's what you're inserting. You're inserting a value. And then again, we have we have parentheses. And then single apostrophe, the value that you want to put into this field, this row, this record. And in this case, we're going to use test value. This could be whatever you want. And please note, yes, it's a single apostrophe, just like here, but it's not remarking it out. In this case, the apostrophes are being used to surround a value, to declare a value. Okay, so let's save that. Go back to our form. We'll save that. Go to view, and we click on our button. It lets you know that one row is going to be appended. You click on yes. Now let's go into that table. There you go. We created a record. We created a row by putting a value for that field. Perfect. And as an aside, you don't have to necessarily use a constant value like we did there. You could use a variable. You could also take a field from a form that's open. We're not going to do that in this example because, again, I'm talking about an automated process that has no data or input from a user, but you can do that as well. So on to the next command. So we will go back to view, design view, make sure the button is selected, event, on click on the ellipsis. We remark this out. And again, we do cmd dot run SQL. Again, that pattern should start to become evident. Let's paste this in. Again, the entire command is surrounded by quotes. And this time, rather than insert into, it's delete from. So you're deleting from what? We're deleting from our table. So here we're going to see an operator that we hadn't seen up to this point, where. So now we're really adding a condition. We want something to happen, but under certain circumstances. So we're deleting a record, we're deleting a row from our table object. Next part is surrounded by parentheses. _name is equal to apostrophe test value apostrophe. So we're saying delete from this object the record, even though record is implied. So delete from our table where this field is equal to this value. And as you know, we just added a record with that value. So let's save that. Save again, view, and let's run it. You're about to delete one row from the specified table. Yes. So you go back to our table. Sure enough, we deleted it. Okay, on to the next. Now, what if you decide that you really need additional fields to be added to the original table? So let's go to Design View. Again, the button selected, Event tab, on click on the ellipsis. Now, when you first create the table, let's just remark this out. When you first create the table, you can add additional fields here. It doesn't have to just be a one-off. But for some reason, you need to add another field. Some department says we want to start tracking such and such. So let's go ahead and add that. So again, docmd.run SQL, and we'll paste this in here. Again, entire command is surrounded by, or should I say, the entire SQL code is surrounded by quotes. In this case, alter table. Which table? Our table. So again, it's using that basic logic of what you're doing to what object, and then any conditions. Add column. Now, in this case, doesn't use parentheses. Does use the bracket though. So we're going to do EE_age. And as you can see, we're going to use a different data type. So up here, we said we're creating a table with EE_name as text. Here it's EE_age with integer. So the formatting of the code is very similar. You have the field name in brackets followed by the type. The only thing that's different is we don't have the parentheses. So when you're doing this, no parentheses required. I just want to point out the differences because sometimes, so obviously syntax always matters. And so it's these kind of inconsistencies in syntax that I want to call out because even one or two symbols out of place is enough to break the line and not work. So I just want to point out these inconsistencies in the way the syntax works. Okay, so again, we're going to alter the table. How are we going to alter the table? We're going to add a column, and it's going to be of an integer format. We save that. We go to View, run it. Doesn't look like anything happened. Go to Our Table, and now you have EE_age. So for whatever reason, certain things you get advisories about and certain things you do not get advisories about. In the words of my database professor, because it's access. We'd say, why is it? And he's like, because it's access, because it's access. So it does lots of things because it's access. And if we go to View and then Design View, you can see, sure enough, it is a number format. Okay, on to the next. So now that we know how to create a table, we know how to populate values into that table, create rows, records. We know how to modify the table itself, the structure of the table by adding columns. Let's now look at dropping the table entirely, deleting the table entirely. So we go to View, Design View, button's already selected, and then we will remark this out. And then again, the same formatting, do command dot run SQL, and again in quotes, and it's drop table as opposed to delete table. So drop table R table. And here's a good example where verbiage makes a difference, that if you were trying to find help with performing this task and you didn't realize the verbiage was drop, you might be searching delete table and not find any results. So that's one of the challenges with coding, is that if the coding is not in the verbiage that you would expect, it might be difficult to get help. And unfortunately, I don't have any answer or any solution for that. But if you're not finding any results, try changing the verbiage, and that maybe that will give you what you're looking for. Because again, even though we said delete for a record, we're using drop for the table as a whole. So it's not delete table, it's drop table. So that's more of an FYI than anything else because, like I said, I don't have a solution. Just if you're not finding what you're looking for, try changing the verbiage. So we'll save that, and then we'll run it. And there you go. The table was deleted. Okay, so I think the last thing to do for this particular tutorial is we'll have them all run in sequence except for the drop table, because what's the point of creating a table and adding to it and putting in rows if we're just going to delete it? So let's go back to design view, and we will remark out the drop. And I think we'll also remark out the delete because we want to make sure that the, whoops, sorry. All right, so we want to create the table. We want to insert a value into the table. We're not going to do the delete of the value because we want to make sure that the addition worked. So we're going to keep create table, insert a value, insert a record, and then alter the table by adding a new column. We'll save that. Save this, and as you can see, the table's not there like we just observed. Run. You're about to append one row. So again, you're not getting a notice that the table is being created. They're just letting you know that you're appending a row to it. And there's our table. And now you have a table that has 2 columns and 1 record. So congratulations, you have an automated process. This is obviously very rudimentary, and that this particular set of commands may not be something that you need per se, so much as this is the foundation of how you create a logical progression, how you have the table created, and that you add values to the table, so on and so forth. So I think this would be a good place to stop for this video. Hey everyone, so picking up where we left off, we are going to look at somewhat more complex versions of the SQL code that we wrote in the last video, and then we'll add a few new commands. So let's go over to our module. And those of you who did not watch the last video, I do recommend it. It's not even 20 minutes long. However, if you don't, what you need to know is that this is the entirety of the code that we wrote. So you're going to wind up seeing a review of most of it anyways. So what we're going to do first is going to create the table again because I want to point out something that I didn't in the last video. So let's go ahead and run our module. We open the table, we go to view, we go to design view, the field is selected, and down here you'll see field properties. So the field properties down here correspond, of course, to whatever field is selected. Now this is a short text field, so it has this attribute of 255 characters. The reason why this is relevant is every time you add a new record, Access will reserve enough memory in order to accommodate those 255 characters. So even if you only put 10 or 20 or 30 characters, Access has reserved enough memory for 255, and we'll do that for each and every record. So in a small database, this isn't a problem, but in a large database with lots of fields that are text and lots of records, that 255 starts adding up. So you have lots and lots of reserved memory that isn't being used. So it creates bloat and could impact the performance of the database. And also, to the best of my knowledge, Access has a 2 GB limit. Not sure if that's still there, but for years, there's a 2 GB limit for Access. So if it's reserving memory, you're going to hit that number much, much sooner. So again, for a small database, not a big deal. But if you're using lots of fields and lots of records, then that starts to add up. So what we're going to do is we're going to look how to restrict that size, because if you determine that you only ever need 30, 40, 50, there's a way to restrict that size and save all that memory. So let's go ahead and close this tab. We'll delete the table. We go back to our module. And after text, in parentheses, put the number 50. We save this. We run it again. Table gets created. We open it up. Design view. There's the field. And now only 50 characters. So you want to be careful because you don't want to do this after your table has already been created and has data, because you don't want to risk cutting off required characters that you've already stored. So make sure you determine ahead of time the appropriate size. Give yourself a little extra room just to be safe. Like, say, in this example, you need 40 characters, so you raise it to 50 just in case your needs change. But now you've restricted the size, so not as much memory is going to be reserved for each and every field of this type. So let's close that, and we go back to our module. Now, let's remark that out with an apostrophe because we don't... Actually, let's do one more thing. Let's delete this table one more time. And let's also show you how to add multiple fields when you create the table, because when you first create a table, it's highly unlikely you're only going to want one field, because a one field table is pretty much useless. You could just store those values in a text file. You could store them in an Excel spreadsheet. So in all likelihood, you're creating a table that has at least 2 fields. So how do we do that? Well, you just add a comma, and now it's rinse and repeat. Follow the same format. Square brackets with the name of the field in the middle. So square bracket, and let's do EE underscore hire underscore date, close square bracket, space, and this one will be of the date data type. So hopefully the pattern is evident. The square brackets with the field name, the space, and then the data type, and then if you have something else, it's just another comma, rinse and repeat. But now that you see 2, you could easily do 3, 4, 5, 6. I'm not going to keep doing more and more examples. Now, I also want to pause and say, if you notice, date here has a specific meaning, has a specific function to access. So you have to be very careful when you're naming fields. You want to avoid one-word names for 2 reasons. So you want to avoid words like name and date, because those have specific meanings and specific functions, and you could potentially cause a problem. You might not, but that's why it's called a best practice, that it might not cause a problem, but it could. So that's the first reason why you shouldn't ever name a field date. You would do something like EE hire date, because you don't want to accidentally name a column that is actually a usable function and has a secondary reserved meaning for access. The second reason is that out of the context of this database, suddenly if you call this just date, suddenly it means nothing. So you export this table, you give it to someone, and they're like, date of what? Hire date, termination date? What does that date mean? So that's the second reason why, and that you want it to be more meaningful, particularly if the data is ever taken out of the database and passed around. That's very common for, say, financial institutions, one line of business, or one group needs to see something that another group actually maintains. So make sure you're naming your fields with meaning, and that is, if you export it out of that table, out of context, the name is still self-evident. So EE hire date would be. So let's go ahead and save that. We go back to our form. We go to our table, and sure enough, there are now 2 fields there. So like I said, no need for me to keep going because you've got this pattern now. Okay, so let's remark this out with an apostrophe because we don't need to create the table yet again. We kept it that time. And let's unremark this one. This is where you create a record in the table. So in EE name, we're going to add a record where the value, let's put the actual person's name in this time. So we just hired Samara Morgan. What else do we want to do? Let's also alter the table. So alter table lets you do various things to the table. In this case, you're going to add a column. So whereas this isn't changing the structure of the table, it's adding a record, this actually changes the structure of the table and adds a column, and the column will be EE age. All right, so let's go ahead and save that. And we run it. You get an advisory that lets you know the rows are going to be appended. I mentioned in the last video that there is a way to suppress these. I'll show you that partway through the video, probably towards the end, because it's technically not, well, not technically, it is not a SQL statement, it's just the VB statement. So let's go back to open up our table, and sure enough, we've added the column and we've added a record. Okay, so let's now remark out that one. But we're not going to remark out this one because we're going to run this one again. So we're going to add another record. But let's do this a little bit differently. What we're going to do with this one is I mentioned that you may not want to add a constant. You may not want to add this static value every single time. Maybe there is a value that is the result of a function running. So you want a value from a function to be saved to the table. So what would that look like? Well, rather than doing name, let's do EE hire date, and we'll put in a date. Well, presumably it will be today's date. So date with another set of parentheses after it. So pretty straightforward. Insert into this table, in this field, a row that has this value. And let's go and run it. Again, you get the advisory that the row is being appended. And there we go. We have a hire date. Now, you could say, well, why would you want to add just a hire date? I'm not saying that this is the preferred way to go about adding the value from a date. Because what you can do is you can just create a table. And when you create the table, you can define default values. So generally speaking, when you create a field, there's some exceptions, but when you create a field, often the default value is blank or null. Auto number is an exception. I believe auto number automatically generates a sequential value. But what I'm getting at is you can declare a default value. So would you ever do this? Probably not, because you could just put in, if you're just using today's date, you could set that as a default value right in the table properties. So I just want to throw that out there because sometimes people say, why'd you do it that way? What I do isn't necessarily the best way to do things. I'm just trying to demonstrate how certain code works. You can then take that code and repurpose it for what you need. But date is extremely easy to tell that it's right. So why create some kind of function and not even be certain what the answer is? We know that the date is correct. Okay, so summary, if you're trying to insert a row into a table, and insert a record into a table, you don't have to just put in static constant values. You can indeed have a value that is derived or the result of a function. In this case, the date function. Now, the next bit of SQL code we're going to look at is going to be the equivalence of an update query. So if we go back to our form, if we go back up to the ribbon, we click on Create. We're not going to go through the whole process, but if you click on Query Design, there's actually several different types of query. This is the one that we're going to focus on. So as you can see, the tooltip says, make the query update the data in an existing table. Now, typically a query like this would probably be used for a bulk change because you could technically manually go into a table and make a single change, but not necessarily. So the bottom line is there is a record that's already existing, and you're going to change some value in that record based on some criteria. So let's close that since we're not actually going to use that. Back to our module. And now, so the format is the same. You have to use a little bit of Visual Basic. So do cmd dot run SQL. So that is Visual Basic saying that you're going to run. What follows next is SQL. So let's just paste this in here so again I don't make any mistakes. So the whole thing has to be surrounded by quotes. So you've got quotes there, you've got quotes there. Update. So like I was just saying, it's the equivalent of an update query. So update what? We want to update something in our table. Now this is a little bit new. We haven't seen set yet. So whereas here we simply say what the value is, here we actually have to say set. So set EE underscore age equals to 32. And if you notice, no apostrophes. Where, we saw where in the first video, where, and now this should look a little bit more familiar. We've got the parentheses, the square brackets, so very similar to the formatting when you're first creating the table with the fields. So parentheses, square bracket, the name of the field, square bracket is equal to, and again, a value is placed in apostrophes. So basically, where there is a record that has this value in this field, put this value into this other field. So the record or records that have this value in this field will result in this value going into this field for those corresponding records. So we want, so EE age will update to 32 for Samara Morgan. Let's run this. Again, you get an advisory. We open our table, and sure enough, Samara Morgan is 32. Okay, so that's about all that I wanted to do for this particular video, with one more exception. I said that I was going to show you a bit of non-SQL coding. So those advisories, they may be annoying, but if you're running an automated process, you really don't want those to occur. Why? Because the process would stop. It takes an automated process and stops it from being automated. So what you can do is you can suppress those. So just be mindful, if you are going to disable these warnings, then it's buyer beware, because you might make a mistake and not know that a mistake has been made. But again, if you're doing automated process, if warnings are being generated, advisories are being generated, then your process is no longer automated. So we'll just paste this in here so I don't make any mistakes, and I can just read through it, but it's incredibly simple. And actually, let's put it at the top. So do command, so again, it's VB, it's Visual Basic, set warnings false. Couldn't be simpler. You are setting the warnings to be not active, to false. So we already saw the advisories as we were running this. So what we're going to do is we're going to delete our table. And we're just going to review the code to see if I have to make any changes. So we're going to create that table. That doesn't generate an advisory. This would generate an advisory if we're adding a value. So a hire date exists, so we can put the date in there. And let's see, we don't have Samara Morgan. I changed that earlier, but at least you knew that this one would create a value. So, create a warning. So you won't see a warning this time. So again, it's just do command dot set warnings false, and obviously the reverse would be do command dot set warnings true. So we'll just save this, and then we will run it. See, the table is so again, the table wouldn't create a warning, but the adding of a record would, and the adding of the record did not. So kind of a double-edged sword, because sometimes you might want to know what you're doing, particularly if you're running like a delete query. You plan on deleting 10 records and it says you're about to delete 50,000 records. Clearly there's something wrong. But again, there might be specific situations where you really have no choice but to shut off the warnings because you don't want an automated process to be interrupted. Okay, so I think that's it for this video. I hope it has been helpful. Hey everyone, so building on what we looked at in the last video, I demonstrated how if you're using SQL to either create a new record in a table or update a record that's in a table, that you don't just have to update with a constant, you can actually use a value calculated from a function. For simplicity's sake, I simply used the date function because that's a predefined function and because it's readily easy to demonstrate if it is correct. So in this video, what we're going to do is we're going to create a module, and in that module, we're going to have a custom function, and then I'm going to show you how to call that custom function in order to put a value into a record and how to dynamically generate the name of a table. Now, whereas I said that you probably wouldn't use SQL to add the date to a record, you would indeed use SQL to generate the name of a table. Why? Well, say you want to do a summary of the day's sales, so you could create a table called 0901 sales. Next day, 0902 sales. Next day, 0903 sales. That way, you have a readily identifiable way of knowing which sales happened when, because they're in that table. If they're not in that table, they didn't happen that day. And then what you could do is say at the end of the week, all those tables are combined into a week ending sales. So sales for the week ending 0907, whatever the proper date is. And then you delete those individual daily tables, or you at least archive them into a separate database so they're not taking up space and impacting the production database. So that's what we're going to do in this video. So let's get into it. So first, a clarification concerning modules. There are two types of modules. We've already been working on one, and that's the one that is attached to the form. It's known as a class module. It's attached to a specific object and is only accessible to that object. We're going to create a standard module which will have functions which will be accessible throughout the entire database. So let's click on Create. Let's click on Module, not Class Module. You can get rid of that at the top. And we enter public function, and the name of what's going to be, let's call it table name, parentheses, as string. We have to say what kind of data it's going to store. And then again, table name without the parentheses this time. We'll give it a value. Since we've been using our table right along, I'm going to use a different value. That way there aren't any concerns that somehow that name is lingering in the background somewhere. We'll give an entirely different name to what we're using. So September table in quotes. We save that. It asks for a name. We'll call this R mod. Now, as before, we need a little bit of Visual Basic, so docmd.run SQL. The entire SQL coding has to be in quotes, and then we write create table, and now, rather than having the constant, this is where we have to address that function. So you start off with the character that's on the tilde key. It's to the left of the number 1. May look like an apostrophe, but it's not. So that symbol, my apologies for not knowing the name of it, and then the quotes, and then the plus, and then the name of that variable we just created. It's table name. So table name, and then you just reverse this, plus, quotes, and again that symbol. And then now I'm going to paste in the rest since we've already reviewed this. This whole section is within parentheses, and this is where you're defining the field name plus the data type separated by a comma. Okay, so we save that. Go back to our form, and then we run it. Sure enough, I should say, the table now has, rather than a constant, it has a function. Now you could say, well, it will always use the same value. This is just the first stage. It's an iterative process. So I wanted to demonstrate that rather than embedding the value right there in the SQL coding, you can reach out to a function, and that would then indeed that function would then generate a value and send it back to the code, to the SQL code. So now that we've done that, now we will add on to this, we'll build onto this so it truly is a variable. So what we do is we go back to our mod, and what we do is rather than September table, let's get we'll just put apostrophe there for now. We might want it again. So table name equals format date, capital D, sorry. So format date, and then the format between quotes. So let's do, I guess, month, day, year, close quotes, close parenthesis. Save that. Back to our form. We can leave that for the moment because it's not going to be the same name. Now, if you noticed, we didn't change the class module because the class module is still going out to the same function. We changed the value within that function. And there you go. So now you have truly taken a variable and used it for the name of a table. So if I was doing this on 9.2, it'd say 9.2. If I do this on 9.3, it'd be 9.3. Again, one of the reasons why you do this is maybe you're in a large financial institution or a large retailer, some organization that really needs to identify the date a transaction occurred. Maybe they do reporting and things like that. So you would create a table at the end of the day for all the transactions stored for that were occurred on 9/1. Next day, this would generate a table for 9/2. Next day, it would generate a table for 9/3. So without changing any code, this will keep changing based on the date. And then maybe at the end of the week, you take all the values from those tables, put into a week table, so first week of September, and then you delete or archive the individual day tables, get them out of the main production database. That way they're not taking up space and slowing down the it's not taking up resources and slowing down the database. So we went from a static to a variable, and now we can kind of combine the two. So what we're going to do now is this we're going to add to. So we have, let's put a plus sign after this, quote, sales. That way the name of the table is a little bit more explanatory. Again, we don't have to change the class module because the class module is going out to the standard module, and that's where we're making the change. So technically we don't have to delete this because the name is going to be different now. So run it, and there you go. So again, this would be for if you're trying to track a specific day's activities, whether it's sales, could be whatever. And then, like I said, you could then take those individual tables and combine them into a week's table. Now that we've done that, let's do something similar, but for a value within a field. So it's very similar, but I just want to demonstrate that to kind of dot our I's and cross our T's. So what we're going to do there is we're going to create another function. So public function, and we could call this current user name as string. And by the way, just in case I didn't clarify that, if you notice, we said it was string, and yet we incorporated a date. So we basically had to convert a date format to a string. That's why we used format. Now, we want to have a current name. So current user name. And this case, we're going to use a constant just like we did for September table. But what you could do is you could modify this function so maybe it captures the current logged in user, or maybe you have the logged in, because you can capture the name of who's logged into the computer itself. Some organizations do that your login to your computer, to the network, is the login to everything. But that's a separate tutorial. So for now, we'll just put a constant in here, but I've already demonstrated how you can build a function of your own. This is, again, just demonstrating that you don't have to use a constant baked into the class module, that the class module can go out to another module and get a value there. Now, this one I'm just going to paste in its entirety since we've already gone through the details, but I will point out a few differences. So again, it starts off with Visual Basic, do command dot run SQL quotes. So insert into table, and we just need to change that because that was from a test I was running, so sorry about that. So table name. So if you notice, this is matching this. So that way, whatever value is here will be here as well. So again, you don't have to revert back to a constant or a string. You are referring back out to that module. That module is going to be the source. And the only major difference here is, if you notice, this works a lot like when I put in the date function, just the name of the function and then the parentheses. So whereas with this function, you don't use the parentheses, with this function, you do. So you can pause the video. I can leave it here for a few seconds, but hopefully that's self-explanatory, that this stays the same and this follows the pattern of using the function name. So we're going to remark that out because we don't want it to create another table. But now that the table has been created, we should be able to run this. And it should insert it into this one. So just to prove it, we'll delete the other ones, because if it's not there, we would get an error. Okay, so we'll go there, and there you go. And just to prove that's working, that was the name that we chose. That was the value we chose. So there you go. So in my previous video, I said I really didn't want to go through making modules, but I realized that just showing you date really doesn't help. It introduces the idea that you can use a function, but I realized you probably wanted to actually see the function spelled out. So now you can dynamically put in values for records, for fields in a record in a table, and you can dynamically name a table. And I just use date because the example that I'm using is maybe retail or banking, financial institutions, some kind of organization where you really have so many transactions that you want to be able to break it down into its own table, even just temporarily. So I think that should do it for this video. I'm trying to keep these videos to under 20 minutes each. I don't know if I succeeded because I had to splice this one a few times, but hopefully that was helpful. And if there's anything else that you want to see, just leave a comment and tell me what you like to see. But as I mentioned in the last video, pretty soon it's going to get challenging, because as the statements become more complex, it's going to be more effort for you to fit it into your database, because basically you have to start swapping out more and more values and put in the field names and the table names. So again, I'm trying to keep this simple enough so that you have basically this template, and then you can apply it to what you're doing. So again, I hope this has been helpful, and have a good day. Hey everyone, so in this video we're going to look at copying all the records from one table to another, and then from multiple tables into just one table. And the example that I used is maybe it is a financial institution or maybe a retail institution, and that the individual tables are daily transaction tables, and now you want the day's transactions to be put into a weekly table. And then, of course, a weekly table could be put into monthly, monthly into year, so on and so forth. So it's the idea of taking a table based on one time frame and putting it into a table of a larger time frame. So what we're going to do is I'm just going to take a couple minutes to create a couple quick tables. I'm actually going to use the wizard since we already demonstrated how to do that using SQL. So create table, home, view, design view, wants a name. This one will be called weekly sales. So therefore this is the one that the records will be copied into. Let's get rid of the primary key. It's not needed for this demonstration. And we'll just call this customer name since we said that these are going to be transactions. And we'll make it a short text. Now, an actual transactional table would have many more fields. It would have, say, transaction time, and maybe it actually stores the payment information as well as what was bought. Maybe there's also an additional field to indicate that it got reversed at a later date or a later time. But having said that, the method I'm going to show you will copy as many or as few columns as you create. In other words, I don't need to add any more columns. The method that I'm going to show you will grab all the columns anyways. So I don't want to waste your time with a bunch of data entry that isn't necessary. And I'll demonstrate, I'll show you exactly what part of the SQL does that for you. So we close that, and now we'll create one of our daily tables. So create table, home, view, design view, and we'll just call this day 1 for now, but we'll probably eventually use an actual date. But again, design is an iterative process. Get rid of the primary key. Again, it's not needed for this particular demonstration. I'm not saying that primary keys are not important, but again, I'm trying to stay focused on just the usage of SQL. So again, very important. The name does need to match, and the data type needs to match. If the name if the name of the field does not match, then SQL won't know what to do. So with the matching names, it makes it much easier. And when you think about it, since you're just taking the same information, why would you have different fields? The very fact that it's in a different table is really the only additional information that we need, and that it's for a certain week or for a certain month. So we close that. Yes, we want to save it. So now we have two tables with the same fields. We're just going to open this one up and put in a couple records. So we've got Samara as a customer. We've got Sadako. That's enough. You'll see that it grabs multiple records. Close that. So this has those two records. This one has none because, again, you're not going to manually put records in here. You're going to instead transfer the records using SQL. Now, for those of you who have not watched the other 3 videos in this series, I do recommend it. I tried to keep them short. Each one, except the first one, I believe, the second and third, are both under 20 minutes, so it won't take you long. But for those of you who don't want to watch those, all we really did, we created a form with a single button, and for the event of clicking on the button, we created a class module, which is this. And just so you know, these are all remarked out, so these aren't even going to be executed yet. This is a standard module, which we will eventually call upon, but at the moment is not being utilized. Okay, so to run a SQL command, you need a little bit of Visual Basic. So do command.run SQL, and then the entire thing needs to be in quotes. So insert into, again, as I mentioned before, SQL is self-documented, that this is literally what you're doing. You're inserting records from one location to another. So insert into weekly sales. That's the name of the table we just made. Now here's something we haven't looked at before. Select. We haven't used select before. Select asterisk. Now this is what I was talking about. The asterisk is a wild card. So I am saying select everything. So select every column, every record, no conditions. That's why I said I only had to create one column, because whether you have one column, one field, or 50, that asterisk will still grab all columns. So select everything from day 1, and that's the name of the other table, and we end with the close quotes. We save this, go back to our database. I always like to save the form just to make sure that it's applied. And then we click run it. We get an advisory that 2 rows are going to be appended. Now, just to be clear, it doesn't remove them from here. Okay, so you're not moving them per se, you're copying them. And let's open our weekly sales, and there we go. So that's the basics of how you copy records from one table to another. Now, obviously, to make this be multiple tables, you would just have day 2, day 3, day 4, day 5. You would just have multiple tables in order. So right now you've got one command concerning one table. You would just, a simple way would be to repeat this out 7 times, and each one grabbing a different table name. Now, to save a little time, I'm going to create a couple tables right now using the wizard rather than, again, going out to the SQL commands. I already demonstrated how to dynamically create a table with a name based on date, so that was in the previous lesson. So, like I said, we're just going to do this using the wizard rather than using SQL, since we already covered that. So create table, view, design view, and the naming is going to be 09, so month, day, 07, and then year 19, and then the word sales is appended at the end, which I'll demonstrate again in the standard module that I pointed out earlier. We get rid of the primary key, again, not necessary for this tutorial. They are important, just not for what we're doing in this tutorial. And again, consistent with the naming, customer name, short text, and we close it, save it. Now what we can do is we can just copy and paste this. So copy, and then paste. There's no data to be copied. We only just created it now. We'll do structure only. So structure is the fields, the data type, but not the actual data. This one would have the data type, or you could use it like an insert into and append them to an existing table. However, we don't want it to be called copy. What we're trying to do is we're trying to change the date. So we've got one for today's date. We'll do one for yesterday, so 06. And then we will do one more. So copy, paste, and we'll make it 05. And again, we'll just do structure only. Yes, I know a week has 7 days, but again, if you see how to do 2 or 3, you can just extrapolate out. I don't want to waste your time with a bunch of data entry. So now we just need to enter some names into these tables. So let's start with 07. So we'll reuse Samara and Sadako, and that's enough. And then for the 6th, we'll have Claire and Rebecca. And then for the 5th, we'll have Jill and we'll have Leon. Close those. So we go back to our modules and we're going to modify this one. So I mentioned that we created a function that created a variable called table name. Well, now we're going to have multiple table names, okay? So what we're going to do is we'll copy this and then we'll make a few changes. Hopefully it doesn't throw an error while we're in the process of copying. So instead of table name, we're going to use the day 1, day 2, day whatever. So we're actually going to go backwards. So today's date would be day 7. And therefore, table name would be day 7. And it would be today's date as we talked about. And by the way, I'm not adding the line. It's doing that when I'm doing the end function and then the beginning of a new function. Day 6 would therefore be today's date minus 1. Day 5 would therefore be today's date minus 2. And you can just keep going on and on and on. Like I said, I don't want to make 7 tables, do data entry. Hopefully you can see the pattern. So day 6 minus a day. Day 5 minus 2 days. And then the rest just keeps the formatting as far as month, day, year, and sales. So now it's just taking these new values and putting them into this. You're inserting, rather than this fixed constant name, you are instead taking those variables. Now we just remark this out and do cmd, so do command, run SQL. So the typical VB at the beginning, the quote, insert into weekly sales, select all asterisks from, and I'm just going to paste this in so I don't make any mistakes, but I will review it with you. Again, as always, syntax tends to be the challenge. So, parenthesis, again, the tilde key without the shift, quote, plus sign, the name of the variable that we're using, and then you reverse, plus sign, quote, tilde key, parenthesis, close quote. We copy this, and it's just rinse and repeat. We want day 6 and day 5. And like I said, if you're doing a full week, there'd be day 5. There would be 7 of these, not 3, but again, I don't want to waste your time making more tables, doing more data entry. I'm hoping the pattern speaks for itself now. So let's go ahead and run this, and then I think we will be done with this lesson. So I did a split partway through where I was testing a few things, so I emptied the weekly sales, so there should be nothing in here at all. So we run. You're about to append 2 rows, you're about to append 2 more, and you're about to append 2 more. So now if we come into weekly sales, Samara Sadako, Claire Rebecca, Jill Leon. Jill Leon, Claire Rebecca, Samara Sadako. So there you go. You now know how to use SQL to combine multiple tables into one. The only thing that keeps this from being an automated process is there are still the advisories which bring it to a halt, but in the previous video, I demonstrated how to shut off the system alerts. So you can just do that. So I think that should do it for this video, and I don't think I really have much more planned for this series. So if there's anything you want to see, please leave a comment and tell me. But from the very beginning, I kind of said that this is where I was looking to go to, is take multiple tables and put them into one. Again, this is the kind of cleanup you would do, the kind of data maintenance and database maintenance you do. You take weekly transactions, put them in, take daily transactions, put them into a week, take weekly transactions, put them into a month, so on and so forth. And then you either delete the tables or you copy them to, say, an offline database, so a non-production database somewhere for archival purpose, and then delete them from your production database. So I think that should do it. Again, if you have anything else that you want to see be done in SQL, or for anything else for that matter, please leave a comment. I'll do my best to try to get that up for you, and have a good day.